Welcome everybody. Welcome to the Success with MySQL session from Facebook. My name is Alex Rodling. I'm with the MySQL team. And with us today is Mark Callaghan, who runs the MySQL engineering team at Facebook. Previously to Facebook, he ran the MySQL engineering team at Google, which happened to be the two most popular websites in the world. And he works very closely with our engineering team to make MySQL a better product, which we greatly appreciate. He's also an active blogger, an active presenter. His blog is called High Availability MySQL. It's very active with lots of feedback and interaction. And with that, please welcome Mark Callaghan.
Thank you. And if you feel you need to ask a question during the talk, that's fine by me. If you want to have your question close to the slide. Otherwise, there will be questions that most of them I can probably answer. There's some numbers I can't talk about, but I can share quite a few details. The topic for the talk is success with MySQL. Before I started working with MySQL, I was working at Oracle for 8 years. About 4 of those years I worked on the database, and it was a great education for how to develop server software. However, when I was at Oracle, I never was anywhere near a production database. So once I began working on MySQL, I had a new education, which is called production. The overview is the deployment we have, I think, is fairly successful, and I'll try to cover some of the aspects of what we do that makes it successful. A lot of the content is anecdotes about the types of problems we work on. Try to cover the goals that we have, the operations team, which is really what makes production successful, the monitoring that they use, the workloads that we support, the types of platform issues we have, and some of the tools. An executive summary of the presentation is the keys to success are hire good people and listen to them. All the process in the world, all of the frameworks, you can buy the best software in the world, but nothing beats having a productive, motivated, responsible team, and I've been fortunate to have that at both Google and at Facebook. So we have a busy transaction processing deployment. Now there's one number that is not on here, and it is the number of servers we have. And so we describe that as X thousand database servers. We think it's one of the larger MySQL deployments. Some of the interesting metrics that we have, the average query response time is 4 milliseconds for select and 5 milliseconds for insert, update, delete. Our focus is on fast statements because most of these queries are run in response to a page request, and we want to draw that page as fast as possible. The numbers I list here are the peak or almost peak performance. The average is a bit less, 38 gigabytes per second for network, queries per second, 13 million queries per second. I think the average is closer to 10. 450 million rows read per second, 3.5 million rows changed per second. That's insert, update, delete, replace. And then about 5 million NODB page operations, so page read or page write. And I'm not sure how that maps back to the disk I/O layer. true disk I/O statistics are a bit tricky to get because we have RAID cards in there, so the RAID card is doing some things that we don't know all of the details of the I/O that it does. Contributions. So here's my advertisement for Facebook. We do think that we contribute back to MySQL. One of the things that we've begun to do is publish tools. The most recent tool was online schema change. Another thing that we have is PMP, which is Poor Man's Profiler. It's a fairly simple shell script that we use for performance debugging, and it's the best performance tool I've used. I'll discuss that more in a future slide. PMySQL is a utility for running queries in parallel across a large number of servers. We publish a lot of patches at Launchpad. Just recently updated the branch to the latest patches we have for 5.1.47, and now I need to integrate up to 5.1.50, and then I'll begin publishing more patches. We do a lot of bug fixes and even more bug reports. I guess you could Google my name on some of the bug reports and you might find a bunch of them. Flash cache is a persistent cache using a Linux kernel module. It's not MySQL specific, but it is optimized for InnoDB. It allows you to use a flash device as a cache, transparent to the application, mostly transparent, although some of the optimization hooks we've already added to InnoDB. But it would sit between the application and your spinning disk. One of my favorite patches is information schema table statistics. There's more slides on this. It just gives you a lot of detail about the workload per table so that you can quickly debug performance problems. And then we have a popular page at Facebook. So reasons why I like MySQL. Number one is solid code. We get very few crashes in production. And when we do get crashes, they tend to be from our patch, much more likely than from the base code that we got. Certainly the software is more reliable than the platform, the hardware that we use. We don't get memory leaks in the code. To me, this is remarkable. The stability. Until we began patching MySQL, which required us to upgrade, we had ridiculous uptimes on these servers. Community is large and educated, so there's a lot of activity, there's a lot of shared knowledge. People are building tools that we can benefit from. Percona does work that we benefit from. It's a bonus for us. InnoDB, I don't know if you've read the source code for InnoDB. I have, and it's just a remarkable work of software development. I don't know if it gets enough appreciation for the project that Heikki started and that the team continues. It's an amazing body of software to work on. And the last reason, I do a lot of benchmarks, and my current numbers, some of the benchmarks are very simple, but they just tell me, best case, what can I do with InnoDB and MySQL? And I have benchmarks now where I can do 180,000 queries per second on one instance of MySQL, and 100,000 disk IOs on one instance of MySQL. And these are remarkable numbers to me, and numbers that make me feel better about the future of InnoDB and MySQL as the platform that we use gets more and more cores and more capacity. We will continue to be able to run MySQL on that hardware. The goals that we have, and these are goals for a successful deployment, we need to have some way of defining the metrics that we care about. And at a high level, we'd like to have no connection failures. That's every time an application needs a connection, we can give it. We'd like to have no query failures, so that whatever SLA exists for individual queries, we want to complete their queries within that response time. We need response time goals. The key with response time is it has to be per query. We have some fast queries, and we have some queries that are guaranteed to have intermittently bad response times. And so we have to look at that number on an individual basis. And finally, replication lag. The slaves are expensive. The hardware is expensive. And if there's replication lag there, the data in the slave is much less valuable. Connection failures, for some of our usage, it's been a problem because we have applications that need too many connections. So generally you'll hear, I can't get a connection, what's wrong with the database? And so we have to go look, and are we suffering from packet loss on the network? Are we funneling 1,000 web servers onto one database server? Do we have bad permissions on the database server? Are we running into a max connection limit? Or is MySQL attempting to do 20,000 connections per second, which it cannot do? The hard part with connection failures is there really isn't anything on the server that allows you to debug the problem. You can see that there's connection failures from show status, but that's it. There's no log of the errors. There's no breakdown of the errors by type or by account. And so while the goal is easy to set, meeting the goal in production is tricky because of the current lack of instrumentation. Query failures. So most of the bug reports I get from internal users start with the database is slow. Mark, the database is slow. And the database slow to me means the application is doing something wrong. It's usually not the database. So is the database slow because there's a deadlock in the application? They're up locking rows in different orders or in a random order so that they're getting a user level deadlock. Is the application prone to lock wait timeouts? Is the query trying to do too much disk I/O in a short amount of time? And the general thing is MySQL has a finite capacity, and the applications usually have much greater than finite ability to demand load. So generally we get the query failures. And again, this is a tricky thing to debug because MySQL, the server, won't report the source of these failures. So for query and connection failures, we end up writing a sample of the failures on the client side, and all of those logs get pushed to a central location, and then we process that log to generate reports on the source of failures. Operations. I've been extremely fortunate at Google and now at Facebook to work with a lot of motivated people who were able to keep up with the problems created by a rapidly growing site. When I started at Facebook about a year ago, they had a few people working on it, and they were very tired. They didn't get enough sleep, and they barely had enough resources to fight fires. So we've grown the team. I'm officially engineering, although I do a lot of production. So we have pretty good relationships between engineering and operations, so that when they say something is really a problem, the engineering believes them. And when engineering says, I really need this schema change or this feature, operations responds quickly. The key, though, is sufficient resources. If you don't have enough people to do anything more than fight fires, then you're in trouble. The other key is continuing education. So a lot of times what I find is you know MySQL when you begin working on it. And after a few years, a few more releases come out, and the people need to have enough time to focus on keeping up with MySQL. We now have partitioning, row-based replication, performance changes within InnoDB. I'm struggling myself to keep up with 5.5. And some of these features are critical for scaling, so we need the time to work on that. Monitoring has to answer two questions. What is happening right now and what happened an hour ago? What is happening right now means you are pulling data in from show status, from InnoDB status, from IOStat, from VMstat, and putting it up in whatever monitoring software you use. What happened means that you have logs of everything that you might want to look at when debugging a problem in real time, and you have some archive of those logs, usually sampled, because you can't afford to archive everything forever. This morning, actually yesterday, I woke up and the row insert rate was increased by a factor of 10 that morning. And that load probably was unsustainable. That was an interesting morning for me. I started with the top down. We had a global rate of rows inserted per second across the database tier, narrowed it down to a few servers that definitely had the problem, and then I used information schema table statistics to figure out which table was there causing the problem. But my typical morning is, the first thing I do is I look at my top end charts. So for the critical metrics, I look at the graphs for the top 10 servers that have a rate that's too high for those metrics. And I look at connection rate, query rate, rows inserted, rows updated, query failures, connection failures. That's, I would say, bottom-up performance debugging. And then I look at aggregate charts. Across the tier, am I doing too much of the same rates or the same metrics to see if there's a problem in aggregate, or is it limited to one or two servers? Then I run pMySQL to look at, I run show process list across all of the servers and order by the runtime of the query to see which queries are running for too long. Then I aggregate the error logs from the database, from the client, to look at connection and query failures to see if there's a pattern. Is there skew such that there's too many failures on one or two hosts, or too many failures from one or two clients? And then I file bugs, and I'm very, very good at filing bugs. Monitoring sources: show process list, show status, show InnoDB status. Slow query log is getting better. You can now actually set a time less than 1 second. You can change it dynamically. For the slow query log, we have a feature to write it to a socket so we don't have to fill a file. MySQL error log, look at to debug individual problems. IOStat and VMstat. IOStat is usually a good indicator of battery failure on the RAID card. And VMstat, generally I look at to determine if there is mutex contention, because there's too many context switches and too much idle time. Extra monitoring sources. This is something that the community, I think, needs to push for. I have, in the Facebook patch, per table statistics. We have the beginnings of per user statistics. I have no idea how most of the world solves a load problem without this data. There's some load problems that I can diagnose within minutes that I'm just not sure how anyone else does it today. Another monitoring problem is what makes this transaction slow. There's a user reporting a problem, the transaction is too slow, and the question is, performance debugging kicks in at that point. You can run show process list and you can see some of the statements from the transaction. You can look in the bin log and you can see the statement's recorded at commit time, so you'll lose some of the timing information. Right now, the key for that is the slow query log for the statements within the transaction that took too long. Some of the statements might have been fast, and so they won't be in there. The other big change with the slow query log is MySQL recently patched it to add in the number of rows examined and fetched for update, insert, and delete, which is a big deal for me. So information schema table statistics. This started out in the Google patch, and we enhanced it for the Facebook patch. Within this, I know absolute values for the number of rows read, rows changed. We added support for InnoDB I/O latency into this. And right now, this is my favorite feature for debugging. So now we'll go on to some of the workload issues. Here's two statements, and the question is, which one would I rather debug? The first one has no comment. From show process list, I can see the client IP address, and that's it. The second one tells me the URL for which the query was done. It tells me the why memcache wasn't used, in this case cache failure, and it tells me the memcache key. So now when I see this, I can investigate, I can figure out which memcache server was used based on the key, and I can check on the health of the memcache server. And I can debug problems in, let's say, 10 minutes that used to take a few hours. This really is a function of the framework that you use to submit queries, and really you need to get the application developers to do this. Memcache. We get a lot of memcache fun because memcache is a utility. It's not a solution. The biggest problem we get is thundering herd on a frequently updated key. So with memcache, you're usually doing, well, you can do write through on the cache or write and validate. We do write and validate, and if the refill query takes too long, frequent invalidation and a slow refill means we end up with concurrent refill. And this is a very painful problem for us. InnoDB purge. So InnoDB purge is the background thread within InnoDB that removes rows that have been marked for delete. So InnoDB, when you delete a row, it's flagged, you change a bit, but you don't remove it. A background thread removes it when no other transactions could view that row. Now the problem is, let's say that you have a table that you're using like a queue. So you're selecting from the front of the table, and you're deleting from the front of the table. The select statement will encounter all of the rows that have been delete marked, but have yet to be removed by purge. I've seen this performance problem at multiple companies, so I assume other people have it. The first time it took about a day to debug, and now it reoccurred at Facebook, and I just remembered from the previous problem that this exists. The problem here is that you'll see that the select is running for a long time, but if you do the select yourself, the additional rows that are delete marked won't appear in the results. So it's kind of confusing to debug. Another issue with purge and delete marking rows is that delete statements, or update, when they encounter the delete marked rows, will lock those rows, even though they're not visible to the user. And so if you have multiple delete statements all attempting to pull off a batch of rows at the start of the table, then they will be encountering these delete marked rows and getting slower in a way that's not very obvious. Continuing with purge. So InnoDB has this InnoDB concurrency tickets feature where a session gets a fixed number of tickets. It could essentially get one row per ticket, and then it has to get back into the queue to get more tickets. So again, if you're using a table like a queue, And if, let's say there's a limit clause, so they pull off a batch of rows each, if the statement runs out of tickets before finishing, it has to go back in the queue. Now the statements that follow it will not make any progress because the first statement has locked all of the rows in the prefix of the result set. But they will keep that first thread from running for some time. The easy fix is increase InnoDB concurrency tickets, but again, it's a non-obvious performance problem. Replication lag, I mean, it seems obvious. The statement runs for 10 minutes on the master. The statement has 10 minutes of replication lag on the slave. The slave runs statements sequentially. You need to educate your users and build up your monitoring to prevent this or to notice it so you can fix it. Avoid long-running transactions. A statement that takes an hour to run can take an hour to roll back. Now the problem is the risk of rollback increases as the statement runs. So if the statement runs for an hour and you think, hey, this statement will probably finish soon, I'll let it run, I don't want to roll back for 1 hour, and then you reach, it runs for 2 hours. Now the risk of rollback is greater. Do you let it continue to 3 hours or do you roll back? It's just a good thing to avoid. Do not allow long-running transactions on your server if you care about transaction processing performance. Contention. This has been a very difficult problem for us. We have a very popular transaction that modifies a hot row. Think of Facebook pages for somebody popular. And so the problem is the transaction is serialized from the point at which the hot row is updated until commit. And so you want to minimize the duration between the two. Now, the first step is to move the update to the end of the transaction. For us, that's actually been a little bit difficult to do. The next step might be to use stored procedures so that there's no network latency between statements. I'm a little reluctant with stored procedures because I don't want to manage a stored procedure per database per critical transaction. The final step is to try to copy what MySQL cluster does, where you send all statements in one RPC, so you have one round trip for your transaction. And we are working on that. So I'm at 10 minutes, so I might speed up on a few slides. DDL has been a recent problem for us. Drop table, truncate table, alter table. Even if the table isn't being used, there's some cases where this statement can lock up the server for a few seconds. And if you care about response time, you don't want a 3-second or a 5-second stall on your server. We're working with InnoDB to advocate for this problem and get the fix. 5.5 actually does much better on this. So we're using 5.1 where it's still a problem. Limit. So limit statement is easily misused. The problem is that people think it fetches 10 rows, so it's cheap. But from a performance perspective, you don't care about the fetch count. You care about how many rows are processed for the query. Explain doesn't really show that to you. The other thing you care about is how many disk IOs are done for the query, especially how many random disk reads are done. And again, explain doesn't show that. So we occasionally have problems. But the biggest one is limit, where you use an offset for pagination. So if you repeat the query every time somebody clicks next, then this is order n squared. And we've had cases where the skip count has been a very large number. And it's very disappointing for the end user waiting for that to return. Index only. If there's one thing you can get for database performance, is get someone who understands index only for InnoDB and how to get the queries to be index only. InnoDB is a little bit better for this. You can really get index only queries because the row visibility data is in the index. Primary key scans are index only because all of the columns are in the leaf nodes of the index. Primary key columns are in every secondary index, even if it's not explicitly listed in the create index statement. And the insert buffer makes it a lot cheaper to do index maintenance. So this is, for InnoDB, is saving us on a lot of performance problems because of this. The only problem is the schema changes to make your workload index only are not easy to do. Query performance testing, simple steps. Explain plan. Run the query and run the show status statement. And then estimate how many disk IOs you're going to do. If you can get your application developers to do this and actually put it into their code review, it can save a lot of performance problems from production. Platform, I will skip. Tools. We have a tool called Pylander. We kill queries to shed load when there's too much load. This frequently saves us from the memcache thundering herd. Pylander was a play on the word, the Highlander movie, because only one query, if there's duplicate queries, only one query survives. And we hope that query finishes and refills memcache. We have other metrics that we're slowly adding to Pylander to determine when it will kill statements. This is actually a small amount of Python to do this, and I've seen this done at multiple companies. It's hopefully maybe it would be good to get this into MatKit. Dogpile, we call, when there's too many queries on a server, we call that a dogpile. Dogpile D is a daemon that archives show process list when that occurs so we can debug problems afterwards. And this is another fairly simple Python utility. TCP dump. When I can't get data from the server, one of the tools I use is TCP dump. The first thing is a command line to figure out what are the most popular queries on the server. It's an estimate. It's a rough estimate, but it frequently works. It would be not, actually, I think this is getting into MatKit, so you don't have to remember this yourself. PMP. This is a shell script we use for performance debugging. Fairly simple, and I think this is getting into MatKit also. It will give you a dump of the thread stacks so you can see where the threads are blocked. And we use this all of the time to do performance debugging to give myself and MySQL the data that they need to debug performance problems. Call to action. Read planetmysql.com. Use 5.5. Blog. Write about your experiences. And join my Facebook page. Are there any questions? No? Okay. Thank you for attending.